Okay, so today we're going to talk a little bit about half-lives, and in order to do that, you need to make sure that you have this sheet filled out, and this is a cheat sheet that you can actually use on your test. So make sure, if you need more time, hit pause, fill this in, and really what we need to be aware of here is that this is broken into two tables, or I guess two pieces of information here, where we have the amount of radioactive material left, and then we also have that as a percent, and then on the other side we have how many half-lives have gone by. So I'll come back to this table here in a little bit here. So number one. So on number one, it says a fossil of an unknown age is found. Scientists determined that the carbon-14 ratio to carbon-12 ratio in the fossil is 1/32 of the ratio found in living substances today. And we need to find the age of the fossil. All right, that's going to be important as well. Now, what I always like to do when I do these problems is I like to underline the half-life, just so I know where that's at, because it's always going to be given to you. So the half-life of carbon-14 is 5,715 years. So what we can do with this problem is we can just, if you ever get stuck on these, I would recommend drawing a picture. So if I draw my picture, right, I got to get this thing down to 1/32 of what it started with. So I started with this whole piece, right? And after a half-life, I'm going to have half of what I started, 1/2, right? Now, how long does that take? Well, my half-life for carbon-14 is 5,715 years, right? I underline that. So for every time I go through one of those half-lives, it's been 5,715 years. So I'm just going to represent that 5,715 years with an arrow to save some time here, so I don't have to write that with a stylus. It's awful. It's ugly anyways. So after another half-life, I'm down to a quarter, 1/4. And if I keep going, I've got an 1/8. And you don't have to make your drawing pretty. Really, you could just represent this with like little slivers, or just so that you know it's going down. Or if you don't need that mental image, just 1/16. Make it a circle, it's fine. And then lastly, 1/32, right? Which is what we're looking to get down to. So the question is, how old is this fossil? How long did this take to occur? If each one of these arrows represents 5,715 years. Well, I can go through, I can add each one of these up, or if I know a little bit of math, right, I've got 5 arrows here. I've gone through 5 half-lives. I'm going to multiply that by my half-life, which is 5,715 years. And when I go through and I do the math, I find that that equals 28,575 years, which is our answer, which is great. So we got to the answer by drawing a picture. Always, always, always an option. Sometimes it might be a necessary option, because we might ask you something that's a little bit more difficult. So if it's confusing to you, try and draw a picture. That's my recommendation. But you might be saying, Roloff, I don't really want to actually have to draw a picture every time. Well, that's okay. We can do this mathematically very quickly, and some of you may have already done it in your head. If you haven't, we actually give you another cheat sheet that you can use to determine this. So we have to remember that the problem tells us how much we have actually remaining. So we actually have 1/32 remaining, which is also this percentage. But that's really not important for us for this problem, because we can now solve it by knowing, and look at that, there's that same number, 5 half-lives. So 5 half-lives have gone by. So let's just take a look at this. Now, I give you this cheat sheet here, and it's broken into two different types. So the first type that we're looking at here is age of the sample. We know this because our problems are going to tell us how much or how long has it been. So we're always going to see some sort of a mention of time. So for these type of problems, look at that. Calculate the age. How many years? How much time? How much time? So in order to figure out which option we want to use on this chart, for that top one, we're looking for something that deals with time. So let's just take a look at these steps and see how you can use them. So this says, step 1, determine how much of the sample is left. Well, that was easy, right? We remember that it was 1/32 remaining. Step 2 says we have to figure out how many half-lives the sample has gone through using the half-life chart. So I'm just going to rewrite this. So step 1 told me 1/32, right? And I have it highlighted there, but let's just write it down. Step 1, 1/32, 1/32 remaining. Okay, so how much? It says how many half-lives has the sample gone through using our half-life chart? Well, our half-life chart we already outlined 1/32 remaining. 5 half-lives, right? 5 half-lives have gone by. So what this means then is that if I have 1/32 remaining, I have gone through 5 half-lives. And if I look back to my cheat sheet, my last step then is going to be to determine the age of the sample. And I have this nice, nifty little equation here. I take the number of half-lives times the time of one half-life. So my 5 half-lives are there. I just need to take that 5 half-lives and I'm going to multiply that by that 5,715 years, which, oh, look at that, it's the same equation I already wrote when I drew it out. I'm still going to get the same answer of 28,575 years. So what I want you to do now is I want you to try number 2, and then we'll go over that one.